Okay, hello everybody. So today we're going to begin talking about something called a slant asymptote, and these go right along with what we've done in the last two videos where we are graphing rational functions. So on occasion, you can end up with something called a slant asymptote as you graph these rational functions. And what you can see is they kind of take the place of the horizontal asymptote in that if you have a slant asymptote, you will not have a horizontal asymptote. And slant asymptotes only occur in one very specific example. And that example is when the degree of the numerator is exactly one higher than the degree of the denominator. So in this particular case, you can see that the numerator is squared and the denominator is to the first power. And so the numerator is exactly one higher than the denominator. And when that happens, you will have something called a slant asymptote. Slant asymptotes cannot occur with horizontal asymptotes because horizontal asymptotes don't occur when the numerator is bigger than the denominator. So, but if it's specifically one bigger, we will end up with a slant asymptote like this. And so I need to show you how to find that. So the way that you find that is you end up doing the division. So what we want to do is go ahead and start this just like we've started all the other ones. We're going to start by finding any vertical asymptotes, maybe any horizontal asymptotes, any slant asymptotes. We will determine if there are any holes, and then we will list the domain like that. Okay, so we start out by finding vertical asymptotes, horizontal asymptotes. Before you do any of that, you actually want to look to see if your rational function that you have will simplify. And the way that you check that is you should factor the numerator and the denominator, if possible, and see if anything cancels out. So you can see the numerator would actually factor into x minus 2, followed by x plus 1, and the denominator would stay x minus 1. In factoring this, you can see that there is not a common factor that would cross out. Therefore, you would not need to worry about any holes. So you could say none for that. Now we can go ahead and fill in what the vertical asymptote would be. The vertical asymptote is filled in simply by taking whatever's in the denominator, setting it equal to 0, and then solving. So we will have a vertical asymptote at 1. Now, as far as horizontal asymptotes go, you look at the degree of the numerator and the denominator to see if you would have any. In this case, the degree of the numerator is 2, the degree of the denominator is 1. So because the top is smaller than the bottom, there is none as far as horizontal asymptotes go. But it does cause us to have what is called a slant asymptote. And again, slant asymptotes happen when the numerator is exactly 1 bigger than the denominator. So we need to go ahead and figure out what that slant asymptote is. And the way that we do that is we simply do this division right here. So we're going to divide x squared minus x minus 2 by x minus 1. Now this is going to require us to do long division, so we'll do x squared minus x minus 2 and divide it by x minus 1. So we will multiply by x, which will give us x squared minus x, and we will subtract those two. You can see the x squareds go away, and then what we're left with is negative 1x minus negative 1x, which becomes plus. So it's negative 1 plus 1, which is 0. So that turns into 0, and you bring down your negative 2. And you can see that the negative 2 is what's left, and that is going to be our remainder. So what we get is we get plus, and then we write negative 2 over x minus 1. And now here's the thing, though. The slant asymptote, we are not worried about the remainder part at all. The only part that we really want to pay attention to is the part that is not the remainder, because that right there, when you set that equal to y, is what gives us our slant asymptote. So we just write y equals x. We do not need to worry about the remainder. The last thing to do is to list the domain, and in this case, the domain is going to be x cannot be 1, so you would write negative infinity to 1 union 1 to infinity, like that. And once we have all that, we can begin to go ahead and graph. Now, this graphing is going to be a little bit different in that there are no horizontal asymptotes, but there is a slant asymptote. So we need to include that slant asymptote. Now, the little bit of strange thing with slant asymptotes is they are not always the same. They can be completely different. It's very dependent on the result that you get when you divide the two rational, or when you divide the rational function that you have. So we'll start out by graphing the vertical asymptote right at 1, right here. And then we're going to go ahead and graph the slant asymptote. And the slant asymptote is y equals x. So that one starts at the origin and then goes up 1 over 1. So we end up with a slant asymptote that looks just like that. So there is our vertical asymptote and our slant asymptote. And as you can see, there are, going by just the vertical asymptote, there are two distinct sections to this graph. So we will go ahead and make a table for each section. And we will pick numbers that are bigger than 1 and smaller than 1. So I will go ahead and put 2, 3, and 4 in there, and then 0, -1, and -2. Now I am going to cheat a little bit, and I said you could do this. You can use your graphing calculator to figure out what the y values are for this by typing in the function in for y1. So that's what I'm going to do. X squared minus x minus 2, and then divided by x minus 1. And now that I have that in there, I can go ahead and hit second table, and I can go into my table and get the x and y values that I need. In this case, I want to go from 4 down to -2. So I'm going to use 4, then 3, then 2. We can't put 1 in because that would give us an error. In fact, I'll show you. You can see how it gives us an error. Then we put in 0, -1, and then -2, like that. And there's all of our y values. So you go 4, and then 3.3, and then 3 is 2, and 2 is 0, and then followed by 0 is 2, -1 is 0, and then -2 is -1.3. So you can see I took all those values from that table and then I filled them in on my XY charts. And then the last thing to do is to take those values and plot them. So I will plot all those points right now. 0, 2 is right here. -1, 0 is here. And then -2, -1.3 is down here. So the graph would look like this. It would curve a little bit and then go up along that vertical asymptote. In a similar fashion, when I plot these points, here is 2, 0, here is 3, 2, and then 4, 3.3 is up around here. We're going to have a graph that'll look like this and curve and then go along that slant asymptote right there. And there's my graph. So I do want to show you one more example. And this one will also be a slant asymptote example. So once again, we kind of start out the same way. We start out by finding vertical asymptote, horizontal asymptote, maybe a slant asymptote, any holes, and then we list the domain. And once we do all that, we can make our tables and plot our graph. So vertical asymptotes come from setting the bottom equal to 0. Now, before I do that, I should try to factor, but if you look at the numerator, it will not factor at all. So you don't even need to worry about trying that. So the vertical asymptote, we set the bottom equal to 0, and that's our vertical asymptote. Horizontal asymptote, we look at the degree of the numerator and the degree of the denominator. 2 is bigger than 1. So because 2 is bigger than 1, the top is bigger than the bottom. There is no horizontal asymptote. But because the top is exactly 1 bigger than the bottom, there will be a slant asymptote. And we need to find that slant asymptote by doing division. So we'll take 3x squared plus 1, and we'll divide it by x. So we will multiply by 3x first, which gives us 3x squared. And then we subtract and we get 0. And then we need to bring this 1 down right there. So we get plus 1. The 1 is a smaller degree than what we're dividing by, however, so we don't need to worry about that. That is the remainder. This is our slant asymptote. So it's y equals 3x. The remainder part does not count. There will not be any holes because nothing's simplified and crossed out from the top and the bottom. And so lastly, we want to go ahead and write our domain, and that domain is made up of looking for any vertical asymptotes and or holes that we have to consider. Here we cannot include 0, so we would have negative infinity to 0, and then union 0 to infinity. Now that we have all of our information that we need, we can go ahead and plot these 2 points. So we have a coordinate plane that we need to draw first in place, and I'm going to go ahead and put, 5 hash marks on each one. That should be enough. Let's see here. Okay, now that we have that, we can go ahead and put in our vertical asymptote, which is at 0 right there. And we can put in our slant asymptote. So that slant asymptote is y equals 3x. So we start at 0, and then we go up 3 over 1, up 3 over 1 again. And you can see there's a line that would be forming there, and we just draw a dashed line through all those like that. And we got our slant asymptote. Now the last thing to do is to go ahead and make a table. So we'll make a table for this side, and we'll make a table for this side, and we'll pick numbers that are bigger and smaller than 0. So in this case, 1, 2, and 3, and then -1, -2, and -3. Now that we have those values, we can go ahead and get our y values. Again, these x values would need to be put into the function. In this case, we can go ahead and use our graphing calculator again. We can use that. It's a little quicker. And we will put in 3x squared plus 1 and divide that by x. So now that we have that in for y1, we can go ahead and take a look at the table. And we need 3, 2, 1, 3, 2, 1, and then we need -1, -2, and -3. And there are our values. So we can go ahead and write all those down. So 9.3, 6.5, and then 4. And then on the other side, we will have -4, -6.5, and -9.3. So now that I have those values written down in my table, you can see that all the y values are written here and here. I can go ahead and plot those. Now I am going to need some hash marks that are farther than what I did. I'll just kind of estimate so you can see. So we'll start with 1, 4. So 1, 4 would be right here. And then we would have 2, 6.5, which would be up here. And lastly, we would have 3, 9, which would be way up here. So what you're going to see is this graph is going to come down like this. And it's going to pull a U-turn and go back up along that asymptote, just like that. And you could extend these asymptotes to see what I'm talking about, how they go right along with that. Now the other part is we have -1, -4, which is right here. We'd have -2, -6.5, which would be down here. And then we would have -3, -9.3, which would be way down here. Once again, we'd have this graph. It would kind of come up here through these points, and then it would kind of pull a U-turn, and it would go back down. It'd look like this. If I extended those asymptotes out, you could see they would come right along there, and then right along there. And then we have the graph of 3x squared plus 1 over x. So as you can see, that's really not too much more to it. Just finding the slant asymptote involves dividing the numerator by the denominator and then taking the whole part and disregarding the remainder part, and then that becomes your slant asymptote. So as always, if you have any questions, feel free to email me. Have a great day.